Yes, sir.
Okay. You must join at 8. It's a new section that we have to start. Anyway, today we shall do the last topic under linear algebra. That is eigenvalues and eigenvectors. Title: Eigenvalues. One word, eigenvalues and eigenvectors. E-I-G-E-N vectors. Eigenvectors, eigenvalues and eigenvectors. That is VEC, vectors. This is C. We have to record.
Recording in progress.
Okay, good morning, students. We shall start the last topic for linear algebra. The title of that section is Eigenvalues and Eigenvectors. E-I-G-E-N, eigenvalues, V-A-L, eigenvalues and eigenvectors. Eigenvectors, eigenvalues and eigenvectors. We shall, before we define these terms, eigenvalues and eigenvectors, let us consider homogeneous linear system of equations. Let capital A be an n by n square matrix is again n by n matrix. Let capital A be an n by n matrix. The linear system of equations. The linear system of equations. We shall write it in the matrix form. Linear system of equations. Linear system of equations. Ax equals 0 vector. This is actually a homogeneous linear system of equations. When this is 0, we say the system is a homogeneous linear system of equations. Okay, the linear system of equations Ax equals 0 has a unique solution. Has a unique solution. If and only if. What is the condition? If and only if determinant of A is not equal to 0. Okay, I gave this as a tutorial problem also. Has a details are not equal to 0. And see, how do we know? And what is that solution? We know homogeneous system always has the 0 solution. If I put 0 vector here, A times 0 vector is 0 vector. So this system always has a solution. It is called so it is in fact, it is not equal to 0. Okay, what is that unique solution? What is that solution? The solution is, what is that solution? That is x is equal to, it is x is equal to 0 vector. It is x is equal to 0 vector. This solution is called the trivial solution. This solution, we did this, this solution is called the trivial solution. Trivial solution. Zero solution. It is the zero solution. It is the zero solution. Trivial solution is zero solution. It is the zero solution. Okay, so for this system to have non-zero solutions, how do we know this? If deta is not equal to 0, so why? If deta, determinant of A, is not equal to 0, then what can you say about the matrix? If deta is not equal to 0, A inverse, what can you say about A inverse? A inverse exists. That is the easiest way to check whether a matrix is invertible, meaning inverse exists. If deta is not equal to 0, A inverse exists. So we did this. I'm just reminding you of it because we need this to do eigenvalues and eigenvectors. If deta is not equal to 0, then A inverse exists. If A inverse exists, in this case, okay, what will happen? Ax equal to 0. Since A inverse exists, we can operate this equation, call this 1. Take A inverse of equation 1 from the left side. So we get A inverse Ax. Ax equals A inverse 0 vector. 0 vector multiplied by any matrix is the 0 matrix. Column vector 0. This x is a vector and we are using this notation. So in fact, what is the shape of x? X is A is n by n. So x is yeah, A is a n by n matrix. Okay. So the linear system. What is this x here? X is and n by 1. It's just a column vector. N by 1 matrix. N by 1 matrix. Meaning just a column vector matrix, i.e. a column vector, a column vector. Only one column. No? So X is an n by 1 matrix, i.e. a column vector, just a column vector. So now you go here. Now we know matrix multiplication is associative. So we have A inverse A X. I can do this too and then take X since matrix multiplication is associative. Okay, now A inverse A is the identity n by n matrix is equal to 0. So X is equal to identity matrix times any matrix is that matrix. So X is a matrix, no column, just n by 1 matrix. So I times X is equal to 0. So if deta is not equal to 0, then X equals 0 is the only solution. It has a unique solution. Determinant not equal to 0. So to have non-trivial solutions for this equation, to have non-trivial solutions, we must have det A equal to 0. So next, understand it, huh? It's equal 0. A unique solution. This is the unique solution. Unique solution is the trivial solution. Now, therefore, if AX equal to 0 has non-zero solutions, if this has AX equal to 0 has non-zero or non-trivial non-zero solutions. If this has non-zero solutions, we must have bit A. Yes, can somebody answer? What should happen? If this has non-zero solutions, bit A should be equal to, if the determinant is non-zero, a unique solution, only the zero solution. That is what we explained in the previous page. So if it has non-zero solutions or non-trivial solutions, we must have determinant of this matrix equal to 0. Okay, that is something that we need when we introduce eigenvalues and eigenvectors. So I did not write the word. This is a homogeneous system of linear equations. Okay, homogeneous meaning this side is equal to 0, right hand side is equal to 0. There are n equations in n unknowns. Okay, A is here. A is like A ij n by n. X is like x1, x2, xn. What is 0? 0 is just 0, 0. So those are the things in this equation. A is this. So when you multiply, you get A11x1, A12x2, A1n xn, and n such equations. All right-hand side, since it's the 0 vector, all of those equations will have right-hand side 0. So without writing the entire thing, I just explained it using the compact form. Okay. Now, next thing we need to motivate you towards eigenvalues and eigenvectors is the matrices as transformations. Matrices as transformations. In fact, they are special type of transformations. They are called, they are examples of, they are not called, they are examples of linear transformations. Matrices as transformations. Let us look at an example to explain what I mean by this. Look at an example. Let capital A be this 2 by 2 matrix. -6, 3, 4, and 5. Okay, and let us take, let A be that, and let us take, let A be that. Now let X be the 2 by 2 column vector. Let us say 1, 1. 1, 1. Okay. Now we can, what is AX? Then AX. We were talking about AX, no? So let us see what AX here is. AX is, A is -6, 3, 4, 5, and then 1, 1. Now multiply out. What do you get? This is equal to, yes? Can somebody give me the answer? This is 2 by 2, this is 2 by 1. You know how to multiply now. So what do we get? What is the first entry? We get a column vector again. Yes? Very silent. Minus 3. Yes, minus 3 and then
9.
9. Minus 6 plus 3. That is minus 3. Then the second entry is 4 plus 5 is 9. Okay. Now think of this. How many coordinates are there for x? There are 2 coordinates. It's when we do matrices, we think of points in the xy plane as in the matrix form. Okay. So if you want to visualize this vector, okay, we say it is the vector going from 0 to the point 1, 1. Okay, x1, x2, 1, 1. Rather than writing 1, 1 in the coordinate form. Now let us visualize this. Suppose this is the x1 axis. This is the x2 axis instead of xy, x1, x2, no x. So this is the origin. Where is the vector 1, 1? Vector 1, 1 is, so what are the coordinates of that point representing that vector? 1 coordinates 1, 1. Okay, 1, 1. So we usually write 1, 1 horizontally. Now here we write them as 1, 1 this way. It's just the just a notation. So it represents the coordinates of the point 1, okay. Now what is AV? That is my vector x. This is my vector x. Where is AX? AX is minus 3, 9. Oh, I don't have enough room there also. Minus 3, no, we have minus 3, 9. Sorry. Okay. AX is minus 3, 9. Represent that minus 3 is somewhere here. This is 1, 1. Minus 3 is somewhere here. 9, let us say, not quite. If this is 1, 9 is somewhere here, I will just put 9 here. And what are the coordinates of this point? Minus 3, 9. So we write them as minus 3, 9 rather than minus 3, 9. That matrix. So what has happened? This is my vector x. This is my AX. So multiplication by the matrix A has transformed, right? This point 1, 1 to another point. So you can visualize matrices as transformations. So this is actually the 2 by 2 situation. x1, x2 transformations in the plane. If it is a matrix, if it is a 2 by 2 matrix, multiplication by that would give us a transformation. The word linear transformations are not there in the syllabus, but I just mentioned that term, linear transformations. They are special type of transformations. Let us get to the eigenvalues and eigenvectors. Okay. So now say for the same example, now take x to be 1, 4. Find AX. Find AX. What will happen? And geometrically interpret it. Then for the same A, then AX is equal to A minus 6, 3, 4, 5. minus 6, 3, 4, 5, A. X is, I'm taking it to be 1, 4. 1, 4. 1, 4 is in the coordinate form, usual coordinate form. Now, when you multiply, what do you get? Minus 6 plus 12. Minus 6 plus 12. That is 6. No? Then the other one, 4. The other one is, yes, 4 plus 20, 24. Now, there is a common value. This is a 2 by 1 matrix. No? The one number is common to both entries. So you can factor that out. Factor 6 out. What do you have here? Yes? When you factor 6 out?
1, 4.
1, 4. 1, 4. So what is AX? So AX is equal to 1, 4 is our vector X. So AX is 6 times X. What has happened in the, if you go to the coordinate plane, x1, x2, okay, x1, x2, in the coordinate plane, x1, x2, let us say my x is 1, 4, so x coordinate 1, y coordinate 4. Let us say 1, 4 is there. This is my x. This is 1, 4 coordinates. AX, what is AX? AX is equal to 6 times that. So in the same direction, we have in the same direction, this is AX. In red, we have AX. That is 6 times, this is the same as, 6 times 1, 4. So AX, which is equal to AX, this is also equal to AX equals 6x. AX equals 6x. Now what happened? After the transformation, they are pointing in the same direction. Okay, if this is a minus, the line would be in the line segment would be in the opposite direction. Okay, so a number which does that is called an eigenvalue of the matrix A. Eigenvalue is, so what do we have here? We see a situation. Now don't get worried. We're going to use a Greek letter, lambda. Now, after COVID, you all know, even the general public knows about Greek letters, no? Lambda. So here, what we see here is, this looks like AX equals lambda x. AX equals lambda x. Okay, so when this happens, AX equals lambda x. This is a special case of that. Geometrically, after the transformation also, it lies along the same line. Lambda positive in the same direction. If lambda is negative, it's in the opposite direction. So I don't want lambda to be 0. What will happen if lambda is 0? After the transformation, it's just the point 0. 0.00 or 0.0 rather. Okay, no direction then. 0 vector has no direction. Okay, so A direction is undefined for 0 vector point. To have a direction, you have to have 2 distinct points. No? So AX equals lambda x. So when we have this type of equation satisfied, any non-zero vector x is called an eigenvector. Lambda is called an eigenvalue. Value for x eigenvalue. Any non-zero x is called an eigenvector. Any non-zero, if x is a non-zero vector satisfying that equation, x is a non-zero vector and vector satisfying the equation, this equation. Any non-zero vector satisfying this equation is called an eigenvector. Is an eigenvector. Eigenvector. Vector corresponding to the eigenvalue lambda. We will write it properly as definitions, but I'm just using that example. There, what is an eigenvalue? Look at this equation and tell me what is an eigenvalue of the eigenvalue. They are all for matrix A. So look at this. X is 1, 4. 1, 4 column vector. Ax is 6 times 1, 4 column vector. So we have Ax equals 6x. So lambda here is 6. No? So 6 is called an eigenvalue of the matrix A. And what is my x here? 1, 4. 1, 4 column vector is an eigenvector in the above example. So so you must be wondering how did I get this vector for this matrix to do that? Okay, once given, we can verify. We multiply, then it came out nicely. So we will do the method of finding eigenvalues and eigenvectors in a minute. Eigenvalues and eigenvectors. Now, looking at the previous example, we can say therefore 6. Therefore, in the above example, 6 is an eigenvalue value of A, and 1, 4 is an eigenvector. Eigenvector corresponding to the eigenvalue. 6. 6 is an eigenvalue. 1, 4 is an eigenvector corresponding to 6. Okay, so that is the motivating example. And now we shall give a precise definition of a eigenvector and eigenvalues. Okay. Definition. Let let capital A be an n by n matrix, square matrix. Eigenvalues, eigenvectors are the inverse. We talk only of square matrices. Okay. Similarly, for eigenvalues and eigenvectors also, A must be a square matrix, be n by n matrix. N by n matrix. It's n by n meaning square. It's a square matrix. Let A be a square matrix, n by n matrix. A non-zero n by 1 matrix, meaning non-zero n by 1 matrix. So n by 1 column vector, non-zero n by 1 column vector, column matrix, n by 1 vector. When it is n by 1 thing, we, instead of saying column matrix, we say column vector, just one column. Okay, written vertically downwards. You know, where for geometric interpretations, we write them horizontally. A non-zero n by 1 column vector is called an eigenvector. Eigenvector is called an eigenvector of A, of the matrix A, if AX is equal to lambda x. If AX equals to lambda x for some lambda, for some scalar, just a number, scalar lambda, for some scalar lambda. In this case, lambda is called an eigenvalue. So we define eigenvector first and then I came to eigenvalue. Lambda is called an eigenvalue. Lambda is called an eigenvalue of A, and this vector x is called vector x, and it's a non-zero vector. A non-zero vector is not considered as an eigenvector. A lambda is called an eigenvalue of A, and x is called an eigenvector. X is called, here also we define eigenvector, called an eigenvector corresponding, lot of theory, no, this is the end, corresponding to the eigenvalue lambda. Okay, lambda is called an eigenvalue. Now the question is, how do we find eigenvalues and eigenvectors for a given matrix? How to find? Now, even if you do not remember the theory, or if you cannot not understand what we did, just very basic things. But anyway, this is the procedure, algorithmic procedure. So the previous things were done for conceptual understanding. Now procedural understanding of how to find eigenvalues and eigenvectors. How to find eigenvalues and eigenvectors. how to find eigenvalues and eigenvectors. Now, what is an eigen? Now, I should box this equation. No? Ax equals lambda x. If so, to find eigenvectors is to find x's satisfied ax equals some scalar lambda times x. So, how do you find this? Go to that equation. Start with this. Hello. Good morning. Hello. That. Yes. Start with ax equals lambda x. Take this to this side. Ax minus, so if this is satisfied, then this must be satisfied. If and only if. This if and only if this. Okay? So if you want to get from here to here, take this to the other side. Okay. In the other side is the same as adding this lambda x to both sides. You get that. If it's there, subtract lambda x from both sides, we get this. Okay, so like for numbers there. No? Now, can I factor x out? Can I factor x out? If I just factor like we do for numbers, we are in trouble. Because then we have n by n matrix minus a number. You cannot subtract two matrices of different sizes. No? Lambda is not even a matrix, it's just a number. A matrix minus say 5. Take this matrix. And if I just write minus 5, it has no meaning. To subtract A minus, if you want to subtract any matrix from this, it must be of the same size. So I cannot factor x out from this equation and say A minus lambda. But I can always use a small trick because I know x is the same as identity n by n matrix times x. Identity matrix, any vector multiplied by an identity matrix, one along the main diagonal, 0 elsewhere. This is I n by n. So I n by n. Because A is n by n. So I n by n times x is n by 1. So multiplication is possible and answer is x. Multiplication by the identity matrix. If you multiply by the 0 matrix, then of course you get 0 matrix. Identity matrix is like 1 in the number system. Now we go here and use that. I cannot subtract lambda from A, but if I write it as ax minus lambda ix, they are the same because of this property of the identity matrix, identity n by n matrix. Now I can factor x out. So what do we get? A minus lambda I. Now that is an n by n matrix because I is n by n identity matrix. No? Times x. Did you understand? Do you understand that? I cannot just write if I have this, then that is not defined even. A is an n by n matrix, lambda is a number, like 6 in the previous problem. It has no meaning, but this certainly, and these steps are all equivalent. Now, this is a, what type of equation is this? This is a homogeneous homogeneous linear, because this side is 0. This is a matrix now, n by n matrix, times x equals 0. That is what we started the lecture with. Ax equals 0. A was a n by n matrix. Here, of course, not A minus lambda I, just a matrix times a column vector equals 0. That gives us, this is a homogeneous linear system of equations. Now use the theory I reviewed, which we had done earlier this morning. This is a homogeneous linear system of equations. Homogeneous linear system of equations. A matrix B times X equals 0 matrix. The homogeneous because of this. It has a non-zero solution. When can that system have a unique solution? When can it has a the system has a unique solution? Unique solution, yes, we did the theory in the morning. First thing we did, what was it? What is the condition? If this has a unique solution, dit A is not equal to 0. If dit A is equal to 0, so unique solution is the 0 solution that we did, 0 solution. That is if dit A is equal to 0. So to have non-trivial solutions, in fact, it will give us infinitely many solutions in that case. This is a homogeneous linear system of equations. For it to have a wait. Yes. Now, what is X? X is an eigenvector corresponding to the eigenvalue lambda for the matrix A. To have an to call this an eigenvector, X must be non-zero. X must be non-zero. So this is a homogeneous linear system of equations. To have non-zero solutions, we must have, it has non-zero solutions. Non-zero solutions, X not equal to 0, a vector. It has non-zero solutions, if and only if, what is the condition? Determinant of the coefficient matrix should be 0. If and only if dit A minus lambda I, should be equal to 0. In some books, instead of writing the DET, they put the absolute value notation. I mentioned that when we did determinants. So in some books they write A minus lambda I. If you write that absolute value notation for matrices, it means the determinant. Okay, so this is in our notation. I just wrote that. If you refer web resources or other textbooks, then you might see this as the notation for determinant. Okay, so now this is a equation satisfied by the eigenvalues. So to find eigenvalues, what we do is we go and solve this determinant equation for lambda. Find values of lambda satisfying this equation. They are the eigenvalues. And then for each eigenvalue, we try to solve this equation, meaning we try to solve this equation to find the non-zero solutions, non-trivial solutions. That is the procedure to find eigenvalues and eigenvectors. So yeah, this equation, this did A minus lambda I equal to 0. This equation is called the characteristic equation. CHAR, characteristic equation. It's called the characteristic equation of A, of the matrix A. Characteristic equation of A. What is the characteristic equation? It is the equation, meaning that A minus lambda I equal to 0. Characteristic equation is the equation satisfied by the eigenvalues of a matrix A. Characteristic equation. That is the name for this. Characteristic equation. Its right hand side, this bit A minus lambda I, this becomes a polynomial in lambda, is called the characteristic polynomial. Characteristic polynomial of the matrix A. Dit A minus lambda I equal to 0 is the characteristic equation. So characteristic polynomial is the left hand side of that equation. So now it's high time. So we know characteristic equation, characteristic polynomial, they are related to eigenvalues of a matrix A. So how do you find the eigenvalues and eigenvectors? So let us go to an example. Find. Now everything should be understood then and there. Earlier, lots of things were said to get to that place, but they are all not that difficult based on the result we did at the beginning to get to this equation, which is called the characteristic equation. The equation satisfied by eigenvalues. Roots of this equation are the eigenvalues. Characteristic equation of A. Shall I also write? It is the equation satisfied by the eigenvalues. So find the eigenvalues. We shall do this together. Eigenvalues and the corresponding eigenvectors. Simply said, find eigenvalues and eigenvectors. Corresponding eigenvectors of let me write it. Of A equals, let us take the matrix to be 3, 2. Let us take a 2 by 2 case, easy. Find the eigenvalues and corresponding eigenvectors of this matrix, of the matrix A given by this. Okay, what is the first thing to do? We have to first find the eigenvalues. How do you find the eigenvalues? We have to solve the characteristic equation. So first write the characteristic equation. Dit A minus lambda I equal to 0. This form or this form. Okay. Now, for that, I need A minus lambda I. So A is this. So what is A minus lambda I? Consider the equation. consider the expression A minus lambda I. I want to take the determinant of this. What is A minus lambda I? Can somebody say? A is this. A is this. 3, 2, minus 1, 0. Minus lambda, what is I? This is a 2 by 2 matrix. So what should I be? 2 by 2 identity matrix. What is it? A minus lambda I. 2 by 2 identity matrix.
1 0
1 0
0 1.
0 1. Now what happens? Not only simplify it, think about what happens. Now, what is this? Minus lambda. Oh, again, 3, 2. This is a mental computation. Minus, multiply this matrix by lambda. What do you get? Lambda 0, yes. Every entry should be multiplied by lambda. 0, when you multiply this by lambda, that is lambda I. Lambda times the identity. Now subtract. What is the first entry? 1 1 entry. When you subtract 3, continue 3 minus lambda. What is the entry here? 1 2 entry. Yes, 2 minus 0. So that is 2. Then here minus 1 minus 0. You have subtract these entries, corresponding entries. So minus 1. What is this entry?
Minus lambda.
Minus lambda. 0 minus lambda. Okay, so what happens when we do A minus lambda I? Without writing all these steps, we can straight away write this. What should be done? From the diagonal, main diagonal, subtract lambda. 3 minus lambda, 0 minus lambda. Other two entries remain the same. So hereafter, we would not do this computation. We straight away, if A is given, A minus lambda I, we shall write it directly. Okay, so now what do I need? What is the characteristic equation? Characteristic equation is the determinant of A minus lambda I. So I need the dit of this. Okay, dit. You can use the absolute notation also. Dit A minus lambda I. What is dit A minus lambda I? That is this determinant. Dit A minus lambda I equal to 0. That is the characteristic equation. I want to solve this for lambda. What is dit A minus lambda I? Just write the determinant. 3 minus lambda, 2 minus 1 minus lambda equal to 0. You all understand how I got the determinant first. So take the matrix A, subtract lambda from the main diagonal, and then take the determinant of that. Okay. Now, let us solve this. This is the characteristic equation. What is the characteristic equation? Find the determinant. What is the determinant? 3 minus lambda times minus lambda. 3 minus lambda times minus lambda, that is product of these two, minus 2 times minus 1 equal to 0. You don't have to write ugly expressions like this. You can mentally do it. When you multiply, you get, what do you get? Minus 3 lambda plus lambda squared. Minus lambda, so mentally also minus 3 lambda plus lambda squared. If you think you make mistakes, you write this step, no harm. Then here we have plus 2 equal to 0. We can multiply by, rearrange terms and write lambda squared minus 3 lambda plus 2 equal to 0. This is our characteristic equation. This is the characteristic equation. We have to solve this equation. It's a quadratic, like x squared minus 3x plus 2. It factors easily. If it doesn't factor, you have to use the quadratic formula. What are the factors? Lambda squared, lambda, lambda. Don't get scared at lambda. It's like x. Plus 2, minus 3. Only factors of 2 are 2 and 1. And this is plus, this is minus. Therefore, both should be minuses. Otherwise, I cannot get plus 2 and minus here. If I put, it should be either plus plus or minus minus. When this is minus, yeah. So now we have lambda minus 1 equal to 0 or lambda minus 2 equal to 0. You don't have to write that step. We can straight away write lambda equals 1 or lambda equals 2. So so all these steps are equivalent. All these steps are equivalent. Therefore, we have this. Therefore, we have, so what are the eigenvalues? Therefore, the eigenvalues are the roots of the characteristic equation. Therefore, so the eigenvalues of capital A are 1 and 2. There are 2 eigenvalues. So the eigenvalues of A are 1 and 2. Now, how do you find eigenvectors? How do you find eigenvectors? Corresponding to each eigenvalue. So what we do is now find, so get 2 cases to consider. Lambda equals 1 case. We write like this, lambda. Okay. Find the eigenvectors corresponding to lambda equals 1. Find the eigenvectors. Eigenvectors corresponding to lambda equals 1. That is what I mean by box. Find the eigenvectors corresponding to lambda equals 1. How do you do that? We have to solve. We must solve A minus lambda I x equal to 0. Eigenvectors. Eigenvectors are vectors satisfying this equation. Now we know the eigenvalues. Okay, this equation is the same as this equation. A minus lambda I x equal to 0. To find eigenvalues, we take the determinant of this matrix and set it equal to 0. With the solutions, each of the solutions, we have to solve this equation to find non-zero solutions of this equation. Non-zero x's in this equation, satisfying this equation, are called eigenvectors corresponding to eigenvalue lambda. A minus lambda I. What is lambda? Lambda now is 1. So this is the same as A minus I x equal to 0. A minus ix. What is A? Do it mentally. We have A minus lambda here. This is the determinant. But as a matrix, A minus lambda I matrix is what? 3 minus lambda, 2 minus 1 lambda, minus lambda. Okay, so now lambda, we have to put lambda equals 1. If you want, you go to the original matrix A Okay, so this is A. No, let me show it. It's easier. A, what is A? A was given to be 3, 2, minus 1, 0. 3, 2, minus 1, 0. Now, minus I, what is I? I is 1, 0, 0, 1. 2 by 2 case now. So, what is A minus I? Subtract the corresponding entries. Can somebody give me the matrix? A minus I matrix. A is this, I is that. So, A minus I is 3. This entry is 2. 3 minus 1. Then here 2. 2 minus 0. Easier if I had written there, but you can mentally do it now. Tell me the second row.
-1,
Minus 1, minus 1. Minus 1, minus 0, 0, minus 1. So, minus 1, minus 1. What is x? x1, x2. Equal to what is 0? 0, 0. All that was. Now, I have to solve this system of equations. Okay, pointless trying to find the determinant of this because the determinant of that would be 0. That is how we came about the value of lambda and came about finding. Right, A minus Ix. Now write down the two equations. What do you see? Something interesting. What is the system of equations now? First equation. 2x1 plus 2x2 equal to 0. When you multiply this side, it becomes what? I don't write this. 2x1, 2x2. When you do the next line, you get minus x1 minus x2 equal to 0, 0. I was going to write. Without writing this, we can straight away write the two equations. This times this is that. This times this is that. Okay, that is what we get. Okay, so skip that line if you can, and now write the two equations. 2x1 plus 2x2 equal to 0. The system becomes this. Minus x1 minus x2 equal to 0. What do you see? The two equations are the, yes? They are the same, no? If you multiply this by minus 2, you get that. So, although there are two equations, we have only one. So, here, both equations give us, if you divide by this x1 plus x2 equal to 0. System reduces to this. System of two equations now reduces to one equation. Okay, we can do this Gaussian elimination or Gauss-Jordan elimination to find it, but in these problems, it's much easier to write down the equations, and there should be dependency. If there are three equations, at least one is, so the one equation is redundant. වැඩක් නැහැ. අනික තියෙන එකමයි එතන තියෙන්නේ. Both are just this. Both become this. So one equation in two unknowns. There should be a free variable. Let, how do you solve this? Let x1 be equal to t. where T belongs to R. Therefore, X2, what is X2? Can you say what is X2? From this equation, X2 is
Yes.
minus T. Minus X1, which is equal to minus T. Therefore, what is X? I won't find X now. X is X1, X2. X1 is T. X2 is minus T. Now you can factor out T. You will have 1 minus 1. So, solution. So, what is T? T is any real number, any non-zero vector. Now here, all eigenvectors, these are the eigen. If T is equal to 0, it's not an eigenvector. This gives us the solution space. Solution space. Solution space. Meaning solution set corresponding to lambda equals 1. We call it the eigenspace. Eigenspace corresponding to lambda equals 1. So eigenspace, what is the eigenspace? Corresponding, solution space. $85. Yes, video එක බලලා මේවා කරයි but power cut එක මේ වෙලාවේ නෑනේ නේද කොහෙවත් ලංකාවේ sad to see. Solution space corresponding to lambda equals 1, that is called the eigenspace corresponding to lambda equals 1. What is the eigenspace corresponding to lambda equals 1? T times 1 minus 1. T belongs to R. That is the solution space. All the solutions in set form, you can write it like that. Every eigenvector can be generated from this. This is a non-zero vector. If you take T equals 1, we get this. Any non-zero. When we talk about eigenspace, we allow T to be 0 also. Solutions of the solution space. Solution space corresponding to lambda equals 1. Eigenvectors are non-zero solutions in that space. So this vector is a non-zero vector and all the others can be generated from that. Multiplying by a scalar. We say 1 minus 1. Okay, this. If you take just that, is a basis. Meaning all the others can be generated from that. There are a little more. It's a term in vector spaces. This set is an example of a vector space. Solutions of homogeneous linear systems of equations. A basis has two properties. Every element we should be able to obtain from the elements in the basis. Okay, and writing as linear combinations. Here multiplying by a scalar. And the members in the basis must be linearly independent. One should not depend on the others. If one can be obtained from other ones, multiplying by scalars and adding, then we say linearly dependent. But those terms are not, I just told you that because the word basis belongs to the vector spaces. So this is a basis for the eigenspace corresponding to lambda equals 1. Okay, that part is okay. If you can come up to this place and you say an eigenvector is 1 minus 1. All the others are multiples of non-zero multiples of that. No? So that part, this part is just just to make it look mathematically elegant and precise. Otherwise, you solve the equation and come up to this place. These things can be easily obtained. Now, why don't you try the other one? There were two. Remember, this is where this whole thing started. Find the eigenvalues and eigenvectors of this matrix. We found dit A minus lambda equal to 0, solved it, and got two values. And then to find the eigenvectors corresponding to lambda equals 1, we completed the thing. Now there is another eigenvalue. Another eigenvalue is, the other eigenvalue is lambda equals 2. Now do the same thing for lambda equals 2. Now say lambda equals 2. How do I find eigenvectors? To find eigenvectors, find the eigenvectors corresponding to lambda equals 2. We must solve A minus lambda I x equal to 0. So you have to memorize that. Characteristic equation is the characteristic equation is the equation with determinant of this equal to 0. The characteristic equation, when you solve, you get the eigenvalues. After you get the eigenvalues, you go back to this equation and you need to find non-zero solutions of this. We are going to get infinitely many solutions because determinant of this matrix is 0 for those values. So first one, we got infinitely many solutions. Now go to lambda equals 2, right? A minus, what is A? What is A? A was minus 6. Now A is 3, 2, sorry, 3,
minus
2.
1, 0.
Minus 1, 0. Very good. Now tell me, what is A minus lambda I? Straight away go to dit A minus lambda. Lambda is 2, no? Sorry, not the dit. A minus, how do I find eigenvectors? A minus lambda I x equal to 0. We have to solve this equation. To solve the determinant to find characteristic values or eigenvalues, that we know. No? After you find the eigenvalues, same thing as we did before. So what is this equation? A minus 2y. Lambda is 2, no? X equal to 0. Write this equation. A is this. So this matrix is this minus, what is 2y? I is 1, 0, 0, 1. So what is 2y? 2, 0,
0, 2.
0, 2. So how do I get A minus 2y? Just subtract 2 from the main diagonal. Don't write this and subtract. Just subtract 2 from the... So what is A minus 2y? Entry here. A minus 2i. 2i is this, no? So these are 0. So when you do A minus 2i, these two entries would not change. From these two entries, we have to subtract 2. So what is the entry here? 3 minus 2y. A minus 2y. 3 minus 2. You get 1. What is the next one?
2
2
minus 1 minus
minus 1
minus
2.
minus 2. What is x? What is 0? Now look again. Now these are the, when you find x1, x2 column vector, we find the non-zero solutions of this equation. They are the eigenvectors corresponding to lambda equals 2. Now how do you solve this one? Multiply out both equations. What is the first one? x1 plus 2x2 equal to 0. Next one, minus x1 minus 2x2 equal to 0. Now this system is the system of equations, but both are the, you know, they must be dependent. Otherwise determinant won't be 0. If you have two good equations in two unknowns, good meaning linearly independent. One doesn't depend on the other. Then you get a unique solution. But here we know determinant is 0. There should be infinitely many solutions. So I cannot have two good equations in two unknowns. One must be, at least one we should be able to throw away. So these are the same, no? Understand it? Because if you take this and multiply by a minus sign, you get this. Or take this and multiply by plus 1, minus 1, then plus x1, minus 1, minus 2, plus x2 equals, that is this. So one of them can be thrown away. So let us cross that off. Cross one system. There are two, just cut it lightly. Yeah? My system is this, but there is only one good equation. The other equation is in disguise, venas swarupekin, the same one. In another form, the same one. Okay, now we know one equation in two unknowns. Oh, mokadda honda? Let. So one variable, one equation in two unknowns. One equation. I didn't write it earlier. Again, now try to understand. One equation in two unknowns. One should be two unknowns. Therefore, one variable can be set free. One, if you are using Gaussian elimination, Gauss-Jordan elimination, you can recognize the free variables. Free variables are variables corresponding to non-leading ones. Leading ones are the leading variables. Here you have one equation in two unknowns. So set one free. Which one should be set free? X1 or X2? If you set x1 free, meaning x1 equals, we took t earlier, no, say x1 equals s, then x2 would be s over minus 2. Fractions are coming. So set 1 free, it doesn't matter. Say x2. So let x2 be equal to s. Where? What is s? Where s is any real number. Where s is any real number. Okay? Now, then this equation, then what is x1? Then x1, that is from this equation. x1 is minus 2x2. No? Take this to the other side, minus 2s. So, vector x is equal to x1, x2 minus 2s, s. Factor s out. -2, 1, where s belongs to R. So what is the basis for the solution space? Eigenspace. So what are the solutions? So solution space, eigenspace, or the solution space. Solution space is equal to these vectors. All these are solutions. Solution space, you can write it in this form, -2, 1. S belongs to R. That is the solution space, set of all solutions. The basis for, so what is an eigenvector? After we come to this, you can immediately say -2, 1 is an eigenvector. Because this is any non-zero solution is an eigenvector. So I can put S to be 1. If I take S to be 1, I get that vector. So that is an eigenvector. Okay, this is one eigenvector. This is one eigenvector. Non-zero solution, one eigenvector corresponding to one eigenvector corresponding to lambda equals 2. This is to mean corresponding to lambda equals 2. All eigenvectors are non-zero solutions. We can put S to be any non-zero number. So solution space is this. Eigenvectors are these vectors without S equal to 0. So what is the basis? Basis for the solution space. All the solutions can be generated from -2, 1. This is a basis. Basis for the eigenspace. The basis for the eigenspace corresponding to lambda equals 2. Basis. Any eigenvector is a non-zero multiple of that. Solution space is the same as eigenspace. This is the eigenspace. But when you talk about eigenvectors, we have to take only non-zero solutions. Basis for the eigenspace. So usually you stop there. We have found eigenvectors. This is one of them. All the others are multiples of that, non-zero multiples. That finishes the problem. Okay. So now let us do, that is a 2 by 2 example. Now let us do a 3 by 3 example. Did it very slowly. Okay. Hopefully you understood everything we did. Now, another example, 3 by 3 example for eigenvalues and eigenvectors. Next example. Then there is nothing new. So it's just the computational complexity that gets increased when you go from 2 by 2 to 3 by 3. Now I will just say let capital A be equal to, take this one, 2 2, 0, 0. 0, 4, 5. Okay, 0, 4. If you help me, we can do another problem also. Huh? Otherwise, time will run out. No. Let A be this. Find the eigenvalues and eigenvectors. Find the eigenvalues and eigenvectors. Find the eigenvalues and eigenvectors. Corresponding eigenvectors. Vectors. Okay, so I just wrote it there. And now what is the first thing to do? We have to get dit. Shall I use this notation? Dit A minus lambda I. Consider the characteristic equation. Instead of writing DET, that is equal to dit of A minus lambda I. I can mukad. I is 3 by 3 identity matrix. 0, 1, 0, 0, 0, 1. We know when you multiply by lambda, this becomes lambda. So A minus lambda I matrix is take A and subtract lambda from the main diagonal. What is the first entry here? 2 minus
2 minus lambda.
2 minus lambda. 0, 0. There's nothing at those places. What is the second row of A minus lambda? 0, yes?
4 minus lambda.
4 minus lambda?
5.
5. What is the last row? 0, 4, last
4
entry?
3 minus lambda.
3 minus lambda. Write the columns properly. Yeah. Now it's the easiest one to. Now otherwise you when it is 3 by 3, 2 by 2 you got a quadratic in lambda. 3 by 3 you get a cubic in lambda. I will if time permits I will do another nice problem. This is an easy one. How do you expand this? Expand this using the first row. Plus, minus, plus. These two are zeros. No? Use first row or even first column. First row expansion. This times, what is it? 2 minus lambda times the determinant, this part. 4 minus lambda, 5, 4, 3 minus lambda. Do you understand? And minus 0 times, 0 times. So no contribution from other two terms because they are zeros. Do this. What do you get? 2 minus lambda, that is bracket 4 minus lambda, 3 minus lambda. Minus, yes? Minus 20. This is equal to, I need to find lambda. No? So here one solution is coming, 2 minus lambda. This one, simplify. 12 minus 7 lambda plus lambda squared minus 20. That is equal to, so this is determinant A minus lambda equal to 2 minus lambda. Then here lambda squared minus 7 lambda. Here minus 8. What are these factors? 2 minus lambda. What are the factors of that? Yes? The factors take care of lambda squared. Lambda. Lambda. I need 7 from factors of 8. So factors of 8, there are 8 times 1 or 4 times 2. So what are the numbers to put? 7, 8 minus 1, so 8.
Plus 1 minus 8.
Yeah, plus 1 minus 8. Plus 1 minus 8. So now what is the equation that we are trying to solve? To find eigenvalues, I have to find this and set it equal to 0. Last time I wrote the equation equal to 0 and wrote down. But here I just took the characteristic polynomial and factored it. Now eigenvalues A minus lambda I determinant, this is the other notation for it, equal to 0 if and only if. What are the values for lambda? Okay, 2 minus lambda, lambda plus 1 times lambda minus 8 equal to 0. That is what was simplified. So this gives us from this factor, what is the value? Values to lambda equals 2 or next one?
Lambda equal minus 1.
Minus 1 or?
Lambda equal 8.
8. So what are the eigenvalues? Therefore, the eigenvalues of A are, what are the eigenvalues? Are 2, minus 1 and 8. 3 eigenvalues. Now, I have to find bases for eigenspaces for all 3 values. Okay, we are doing okay. So it will take a little time, okay, to do there are 3 places. No, let us target 10 minutes for that. Huh? So I can get the other one also in there. So now for eigenvectors, so I have to consider 3 separately. Lambda equals 2. So eigenvalues we have found. Now to go for eigenvectors. Now we put lambda equals, what is the smallest one? Minus 1. So let us go by that. Lambda equals minus 1. Then 2, 8. Lambda equals minus 1. To find eigenvectors, we have to consider A minus lambda I x equal to 0. We can solve it. So what is A minus lambda is? Lambda is minus 1. We found A minus lambda I here. Determinant form, but matrix is just the 2 brackets there. No? So A minus lambda is minus 1. If lambda is minus 1, this is 3, 5, 3, 5, 4. Lambda is minus 1. Or take this and subtract minus 1. Subtract minus 1 is add 1. So 3, 5, 4. This is 3, 5, 4. First line 3, 0, 0. A is this. I'll keep A. Subtract minus 1. So meaning add 1 to diagonal entries. Second one 0, add 1 to this 5, 5. Last one 0, yes, 4. What is the last entry? Lambda is minus 1. So that is the same as A plus I. Add 1 to, so this is 3. Minus 1 is plus 1. 3 plus 1. This is going to be 4. Terima. තේරුම් නැත්නම් කියන්න x1 අනේ ඔයගොල්ලෝ chat එකට දාන්නේ නැහැ මොනවාත් මට නිකන් හරි කියවන්න 0 0 0 තේරෙයිම හරිද a වලින් a minus lambda is minus 1 මෙතනත් හොයලා තියෙනවා ඒකත් පාවිච්චි කරන්න පුළුවන් okay a minus lambda is that lambda is minus 1 so a plus I write down the equations Kianu, what is the first equation write the three equations now
Sir,
yes
x1, x2, x3, the x2.
oh 3 3 oh. Yes very good x1 x2 x3 thank you what is the first equation 3x1 equal to 0 second equation
Excuse me, sir.
yes
Sir, अपने lambda minus 1 නිසා අපි අපිට I එක minus 1 වලින් වෙනස් වෙන්නේ නැද්ද?
oh මම පෙන්නන්න I එක -1 වලින් වැඩි වෙනකොට මොකද්ද තියෙන්නේ -1 දාපුවාම මෙතන එන්නේ a plus I නේද
සර් ඒතර මේ අර මුලින්ම අර I එක වෙනස් වෙන්නේ නැද්ද අර මේ
I එක I වෙනස් වෙන්නේ නැහැ නමුත් මයිනස් කරනකොට මම ආයෙ පෙන්නන්න අර එතකොට ගොඩක් ලියන්න ඒව A කියන්නේ මොකද්ද but we have to do this A කියන්නේ ඒව ලියමු 2 මම මේක පෙන්නන්න යන්නේ how did I get this A minus lambda I අර හිතෙන් කරන එක තමයි හොඳ take A අපි මම කරලා ඉවරලා පෙන්නලා ආයෙම කියන්න එතකොට ඔයාලට තේරෙයි හොඳයි 2 0 0 0 4 5 then 0 4 3 මේක තමයි A this is A minus lambda lambda කියන්නේ -1 so minus 1 can plus 1 1 0 0 0 1 0 0 0 1 අර තේරෙනවද මේක දැන් a minus මේ lambda ට minus මට ඕන මෙතන minus උයි තව -1 කියලා දාන්න තිබ්බා මේක තමයි a minus lambda I කියන්නේ දැන් මොකද වෙන්නේ මේක සමානයි මොකකටද මෙන්න මේ තුනට එක අහුවෙන එක විතරනේ අනිත් ඒවාට එකතු වෙන්නේ නැහැ මොනවාත් දැන් කියන්නකෝ බලන්න
හරි
හරි නේද එතකොට මේක එතකොට අරක එනවා එතකොට අර එකපාරට කරන්න පුරුදු කරන්න දැන් මේකත් මෙතන ලියලම දාමුකෝ main diagonal add 1 3 add නෙමෙයි subtract -1 කියන්නේ adding 1 ඒක තමයි 0 5 5 5 last one 0 4 3 වලට එකක් add කළාම 4 එනවා හරි නේද a minus lambda ඉව ගත්තා කොහොමද තේරුණාද so දැන් ඔන්න එතන තමයි ඉන්නේ a minus lambda I x කියන්නේ x1 x2 x3 ආ දැන් මට සමීකරණ තුන කියන්නකෝ බලන්න පළවෙනි සමීකරණය මොකද්ද? 3x1 0x2 0x3 ඒකනේ first entry එක එහා පැත්තේට සමානයි කියන්නේ ඒක බිඳුව වෙන්න. මට help කරන්න නැත්නම් අපිට අනිත් එක කරන්න වෙලා මදි වෙයි. 3x1 තාම lambda පළවෙනි එකනේ 3x1 equal to 0. What is the second equation? ඉක්මනට කියන්න.
5x2
5x2
plus 5x3 equals 0.
Last one.
4x2 plus
2 plus 4x3 equals 0.
Yes, very good. Now we know at least one we have to throw away. If there are 3 equations in 3 unknowns, but they cannot be 3 good equations. If three good equations here, this equation and this equation are the, yes, they are the same, neither. So you can throw away one. Both of these equations, okay, they are the same equation. So don't have to have both, no. So the system reduces to 3x1 equal to 0 and one of them. Now from that we can say straight away x1 equal to 0. If 3x1 is equal to 0, x1 is 0. And second equation, x1 plus x2 plus x3 equal to 0. Both of them becomes this. So system make about path. Now x1 we have a specific value. These two unknowns, one equation. One should be free. Let x2 be equal to t. T t. Where t belongs to r. What is therefore x3? X3 from this equation. X3 is equal to minus x2 minus t. So partly work. Therefore, x is equal to x1 0, x2 t, x3 minus t. Take t out, you get 0, 1, minus 1. Which t belongs to R. Now you can write the basis like sorry. Get this. So what is the basis for the eigenspace? 0, 1, minus 1. So solution space corresponding to lambda equals minus 1, corresponding to lambda equals minus 1 is set t times 0, 1, minus 1. T belongs to R. ඔක්කොම eigenvectors හොයලා තියෙන්නේ මෙතෙන්ට එනකොට. ඉතින් එතනින් පස්සේ ඉවරයි problem එක. මේ නිකන් බොරුවට ලියනවා. So basis එකක් මොකද්ද? And basis එකේ කොච්චරක් elements තියෙනවද? මට මේ අර basis එකට elements එකකට වඩා එන example එකක් කරන්න ඕනේ. I want to do an example where basis consists of more than one vector. මේ වයිදී t times that. So this is a basis. Basis for the solution space. This is one eigenvector. Eigenvectors ඔක්කොම හොයලා ඉවරයි මෙතන. Eigenvectors are non-zero solutions of this. මේක basis එක කියපු ගමන් දන්නවා. Any non-zero vector generated from this by multiplying it by a scalar is an eigenvector. Okay, lambda. Yes. Okay. Now, what is the other one? Current lambda equals, what were the eigen values? Eigen values were lambda equals minus 1, 2, and 8. Then yamu lambda equals 2. Lambda equals 2. So a minus lambda I. Lambda is 2, no? 2i. A minus 2i x equal to 0 tamai solve කරන්න. That is what we need to solve. Sorry, time is speaking, students. Yes. Now what is a minus 2i? What is a? A is 200 0 4 5 0 4 3. A minus 2i. A is this. So a minus 2i cal. Oh, මොකද කරන්න ඕනේ? මේකෙන් වෙන්නේ from this, okay, when you multiply I by 2, it becomes 2, 2, 2 in the main diagonal. All the others are zeros. So This amounts to subtracting 2 from the main diagonal. What is the matrix? A minus 2i. A is this. What is this entry? Look at the diagonal elements. 2, 4, 3. Diagonal elements of this are 2, 2, 2.
0.
Yeah, 0. 0, 0, 0. What is the next line?
0 to
0
5.
to 5.
0, 2, 5. Next one. 0,
4.
4.
1.
Minus 0, 4.
1.
Very good. Equals, times x1, x2, x3 equals 0, 0, 0. What are the equations? Nothing. First equation not there, no? Second equation. First equation is not there. Second equation, 2x2, 2x2, here 0, 0, 0. So you get 0 equals 0 is the first equation. Second equation, 2x2 plus 5x3 equal to 0. Last equation, 4x2 plus x3 equal to 0. Now I have only two equations. This is 0 equals 0. No? From these two, so this is my system. From these two, I get x2 equal to 0. Look at the determinant. 2 minus 20 minus 18. Determinant is non-zero. This is two equations in two variables. So x2 must be 0, and without solving like O level, I just take the dit of, now think of, forget the entire problem. Now just look at these two equations. What are the solutions? It's in the matrix form, 2, 5, 4, 1. 2, 5, 4, 1. What is the determinant? Determinant of that is not equal to 0. Homogeneous system of linear equations did not equal to 0. Therefore, 0 solution is the only solution. Now, so what is x1? Therefore, x2 equals to 0 and x3 equal to 0. First, what is x1? x1 is free. Conditions, x1 must be free. So let x1 be equal to s. So x is equal to x1, x2, x3. S 0, 0. S factored out, it becomes 1, 0, 0. Then put one is eigenvector. This is an eigenvector. It's a basis for the eigenspace. Okay. And all eigenvectors are non-zero multiples of this. So now go to lambda equals 8. Solution like I have done it. Lambda equals 8. Basis corresponding to lambda equals 2 for the solutions. Space. Effective. Most effective. Basis for lambda equals 2 is this. Any eigenvector can be generated from this. All you have to do is multiply it by a non-zero constant. Lambda equals 8. Now, what is a minus again? Now, a minus lambda is 8. Now, 8i. A minus 8i. X equal to 0. Now, tell me, look at a. Without wasting time to rewrite. This is a, no? A minus 8i. 8i now. Meaning, you have to subtract 8 from these 3. So what is the first entry? 2 minus 8 is minus 6. Minus 6. Minus 6. 0, 0. Ready? 0, 0. X1, X2, X3 equals 0, 0, 0. Then I subtract 8 from this entry. Minus 0, minus 4, 5. 0, minus 4, 5. Subtract 8 from this entry. This is A. 4, 0, 4, 8 minus 5. 0, 0, 4 minus 5. 0, 4 minus 5. Interesting thing happens now. Okay, then මේක ලියාගන්න පුළුවන් කොහොම හරි. A minus. Take A and subtract 8 from the diagonal entries. Write down the system. Minus 6x1 equal to 0 as before. Second equation. Minus, not as before. Earlier it was 0 equals 0. Now minus 6x1 equal to 0. Second one, minus 4x2 plus 5x3 equal to 0. Last one, yeah. Oh.
4x2 minus 5x3 equals 0.
Very good. Now those 3. One equation. First equation we need x1 equal to 0. These two are the same. So take one off. Either one is okay. If you take this and multiply by minus sign, you get this. They both need not be there. So what are the solutions? X1 is equal to 0 and this 4x2 minus 5x3. 4x2 minus 5x3 equal to 0. Only 2 equations now. They are the same. So cross that off. Don't need. So now one equation in 2 unknowns. X1 is here. Settled. X2, X3. So here it doesn't matter. Take X, let X3 be. Let X3 be. What did we use? Let us say U, where U belongs to R. Therefore, this equation tells me X2 is equal to 5 over 4 U. Fractions come in. What to do? 4x2 is 5x3. Divide by 5x3 over 4. Okay, so what is x? Vector x is equal to x1, x2, x3. x1, x2, x3. And what is x1? x1 is 0. x2 is u. x3 is 5u over 4. Ugly. So factor out.
X2 equal 5u over 4.
Exactly.
X2 equals
5 for 5u over 4.
yes, that's
X3
what
equals
I took x3 equals u, no? One variable free, no? I can take it for anyone. Yes, I know earlier ones I took x2, but here I took x3 to be u. One variable free. So what is 4x2 then? 4x2 is equal to 5x3. 5x3. So x2 is equal to 5 over 4 x3. What is x3? I took x3 to be u. So it is 5u over 4. Correct? Do you understand it? You understand how I got this then? Work is shown there. Okay. මොනවද වැරද්දක්ද? කොහොමද උඩ තියෙන තේකනේ 4x2 minus 5x3. 4x2. හරිද? Okay. උත්තර දෙන්න ලියස් කියන්න ඕනේ. තේරුණා නැත්නම් නෑ කියන්නේ. Didn't understand? මේ 10 වෙනවා. So 1 minute. කියන්නකෝ ඒ අහපු එක නා තේරුණාද? තේරෙම? හා?
X එකේ ලියුම හරි. අර අන්තිමේදී ලියුව එක සර්.
ඔව් මෙහෙ ලියපු එකනේ.
නෑ අන්තිමට ලියුව. නෑ සර් පල්ලෙහා.
මෙතනද?
අවසානම හරි සර්.
හා?
පහළ ටික.
ඉතින් හරි නේද 5u4. අයියෝ. ඒක තමයි මේක මාරු වෙන්න ඕනේ නේද? x2 නෙමෙයි. අනේ sorry. Yes. Ayo, see. This should be, yes, very good. What is x1? x1 is 0. Eka 0. What is x2? x2 is 5u. Ayo, mama, monad explain karne me lama akkom theruma lagindi. Making, we shall, if you want things without fractions, you can factor out u. But if I factor out u over 4, it's a lesson 0, 5, I have to put 4 there. Oh, you factor u out and 0, 5 over 4, 1. Yes, that is to remove fractions in the basis. No such requirement. So this is a basis for, or just leave it as, if you don't want to do that, 0, 5 over 4, 1. 0, 5 over 4, 1 is also okay. It's 10, 1. I'll ask, yes, from there. I will put oh, then fill out my just wanted to give you a problem to work on. Make it done. When I upload the thing, I'll put about 3 problems. So make it either. Yeah, try the problems given in the tute now. I didn't ask you to submit. We shall stop there then. How those.
Thank you, sir.
Okay, you are welcome. You have a lecture now.
Thank you, sir.
You are welcome. You are welcome. Yes. So the tutorial, I will write a solution and upload. I will do another problem and upload. See whether you can understand it. Otherwise, next Friday, I will start differential equations. Please brush up your integration skills. Integrals ගැන පොඩ්ඩක් integration ගැන බලාගෙන එන්න. නැත්නම් ඉවරයි. Lazy, but you need to integrate. ඉතින් අපි ඒ ටික බලාගෙන ඉන්නකො sir a minus bi ගත්තු විදිය කියලා දෙන්නකෝ. මම a minus 8 I ගත්තු විදිය. Right. The lecture is over, but since the student is asking how I got, the students having classes go, this will be uploaded. ඒකට මේ ටික කමන්නේ නැහැ theory නේ. a minus 8 I ගත්තු විදිය කියලා දෙන්නලු. How I got a minus 8 I. අප මම හිමීට කරන්නම්. a minus 8 I. a minus 8 I නේ ඕනේ. ලියන්නකෝ a was given to be a 20 මේ a ව දුන්නා 200 දීපු a ලියන්නේ 0 0 4 5 අන්තිම row එක 0 4 3 minus 8 8 I කියන්නේ මොකද්ද කියන්නකෝ පුළුවන්ද 1 0 0 0 1 0 0 0 1 identity 3x3 matrix එක තේරුණාද එතෙන් දෙනකම් දැන් multiply කරන්න මම සමහරක් වෙලාවට දැන් අපරාධය 405 එක කොහේ බම් බලනවා මොකක්ද එතන වැරද්ද කියලා බලන්නකො නේද minus 8 වැඩි කරාම මේකේ ඉන්නේ මොකද්ද වැඩි කරන්න 8 0 0 මෙහෙම හිතපුවාම හරි මේවා ටික 8න් වැඩි කරන්න තියෙන අරවා බින්දුනේ 0 8 0 0 0 8 දැන් මේකෙන් මේක අඩු කරනවා කියන්නේ මොකක්ද for these entries මේකෙන් මේවා zeros නේ එතකොට these entries and these entries ඒවා අරකේ තියෙන ඒවාමයි වෙනස් වෙන්නේ නැහැ no change ඒ වුණාට diagonal එකේ මේකෙන් මේක අඩු කරන්න ඕනේ නේද එතකොට 2 minus 8 හරිනේ අඩු කරන්නේ එහෙමනේ corresponding entries 2 minus 8 එතකොට එන්නේ මොකද්ද 2 minus 8 මේකෙන් 8 ගානේ අඩු කරන්න minus 6 0 0 ඒකනේ first row එක අඩු කරාම ඊට second row එකේ මේක මෙරෙම ඒකමයි 4 minus 8 4 minus 8 can minus 4 හරි නේද 4 minus 8 can minus 4 ඊට පස්සේ 5 වලින් මොනවද වෙනවද නෑ ඒවා මේ ටික විතරයි මේ ටිකෙන් ඔය ටිකෙන් අර 8යි i නම් 8 අඩු කරනවා 7යි i නම් 7ක් අඩු කරනවා ඍණ i නම් if lambda is minus I එතකොට a plus I වෙනවා එතකොට කොහොමද කරන්න ඕනේ මේ row එකෙන් අඩු කරන්න ඕනේ lambda අඩු කරනවා කිව්වම lambda ඍණ නම් එකතු කරනවා 2 minus 8 හරි නේද දැන් මෙතන minus 4 this is 5 අන්තිම row එක කියන්නකෝ 0 4 මෙතන කීයද 3
minus
yeah minus 5 3 minus 8 minus 5 එහෙම තමයි a minus 8 ඉතින් මේවා ලියන්න එපා කරන්න ඕනේ a ව ගන්න take a කොච්චරද 2 0 0 0 4 5 0 4 3 take a and subtract lambda from the main diagonal making main entries වලින් minus 8 lambda කියන්නේ 8 නේ minus 8 from those so එකපාරටම මේකේ නෝ 2 minus 8 කියන්නේ minus 6 4 minus 8 plus 4 minus 8 මේකෙන් අඩු කරලා minus 4 මේක ගන්න මොකද කරන්න ඕනේ මේකෙන් minus 8 minus 8 තමයි එකතු කරන්නේ නැත්නම් 8 අඩු කරන්නේ තේරුණාද ස්ටුඩන්ට් අහපු කෙනා මට කියන්න තේරුණාද කියලා දැන්
yes sir
එහෙනම් අනිත් example එක upload කරන්න කටියන්න නැතුව කරන්න ඕනේ. Now that we have tutor එකේ තියෙන problems පටන් ගන්න කරන්න. tutor එකේ problems කරන්න. upload කරන්න වැඩක් නැහැ. tutor එකේ ඒවා කරන්න පටන් ගන්නකො මේක දිහා බලලා. Try look at this and then try to do the problems in the tute. Repeated root එකකට මම සම්රිට හරි කියන්න. It's the same. Maybe not in the basis එකට the basis gets more than one element. All the problems we did, basis of the solution space consisted of one vector. ඉතින් අර linear combinations of two vectors එනවා. ඒක ලස්සනයි. ඒක කරන්න ගත්තොත් අනිත් දවසේ මට පටන් ගන්න වෙන්නේ නැහැ මේ differential equations. බලන්න මොකක් හරි ක්‍රමයක් දාන්න බලන්නම්කෝ ඒක. එයින් එකක්. හරි. අනිත් මේ මම මෙතන හංගලා තියෙන්නේ අමාරු හරිය. ඒ කියන්නේ here determinant of this determinant එක lazy factor කරන්න. Because one linear factor was there. Sorry, I will speak student. Here the determinant factored nicely in the problems we had. But in general, okay, determinant might not factor that quickly. How to solve cubic equation solve can't do. You need factor theorem. Factor theorem. You can use the factor theorem. බලමුකෝ අපි. තව ටිකක්. හරි කරන්න බලමු. හරි. කරපු ටික තේරුණානේ? So see you on Friday.
Thank you, sir.